This is Unit 2, Lesson 16, Geometric Sequences. Yesterday in class we talked about arithmetic sequences, and an arithmetic sequence has a common difference, meaning that you add or subtract the same amount every time to get the next term in the sequence. Geometric sequences have something similar, but this time we don't use addition and subtraction. So let's go ahead and start off with our vocabulary. We have two vocabulary terms today. The first one is geometric sequence. Remember, a geometric sequence is similar to an arithmetic sequence, only this time it's the ratio of any term that is constant to the previous term. So our definition is ratio of any term to the previous term is constant. So in an arithmetic sequence, we are adding or subtracting the same amount every time. In a geometric sequence, you are multiplying by the same amount every time. So we have a name for that number that you multiply every time, and that is called the common ratio. The common ratio is very similar to the common difference in an arithmetic sequence. Our common ratio is that constant ratio between terms, and we represent it with the letter R. Before we move on, I have a question that I want you to think about, and that question is, how is a geometric sequence different than an arithmetic sequence? So take a minute to think about all of the differences between arithmetic and geometric sequences, and maybe jot down some of the ideas that you come up with. Now let's move on and talk about how to identify geometric sequences. In a geometric sequence, we are looking for a common ratio. So that means the second term divided by the first term has to be equal to the third term divided by the second term, and the fourth term divided by the third term. So you are taking every term and dividing it by the previous term. Another way we can write that is a sub 2 divided by a sub 1. So the second term divided by the first term. That would need to be equal to the third term, or a sub 3, divided by the second term, a sub 2. And that continues on. So this ratio has to be common. It has to be constant throughout the entire sequence. Let's look at 4 different sequences and decide whether or not they have a common ratio, whether or not they are geometric. The first sequence we're going to look at is 1, 3, 7, 13, 21. So I do the second term, which is 3, divided by the first term, which is 1. And that equals 3. Now let's look at the third term, which is 7, divided by the term previous to that, or the second term, which was 3. 7 divided by 3 is 2.33. We already know it's wrong, but let's just go on and do the third term divided by the second term. And that's 1.857. So we have 3 different ratios here. They are not the same, so that means we have no common ratio. Let's look at another sequence and see if it's geometric. This sequence is 3, 6, 12, 24, 48. So I'll do my second term divided by the first term, which is 2. Next we have the third term, 12, divided by the second term, 6, which gives me 2. So far we've got 2 numbers, 2 ratios that are the same. Let's just keep going and make sure this pattern is constant through the whole sequence. So the third term divided by the second term gives me 2. And then finally that fourth term divided by the third term also gives me 2. So in this example, I do have a common ratio. The common ratio is 2. Let's look at one more example. This sequence is 16, 64, 4, 1. Oh, I said that wrong. This sequence is 64, 16, 4, 1, and 1/4. So I take the second term, divide it by the first term, and you might get a decimal of 0.25, or you could get a fraction of 1/4. Now let's do the third term divided by the second term. That fraction reduces to 1/4, or it also divides to be 0.25. Then we have 1/4, which doesn't reduce, it's just 1/4. And then we can do the fifth term, 1/4 over 1, which is just 1/4. So you can see every time we have this common ratio of 1/4. Or if you do 1 divided by 4, you would find the common ratio is 0.25. So sequence A and sequence C, A and C, are geometric sequences because we had a common ratio. We had the common ratio, oh, sorry, I said that wrong. Sequence B and sequence C are geometric because they have a common ratio. We have the common ratio of 1/4, and then we have the common ratio of 2. Sequence A is not a geometric sequence because that ratio was not constant throughout the entire sequence. Now we're going to move on to the rule. And I'm writing this big because it's very important. So I want you to make sure you write it large in your notebook or circle it, underline it, do something so that you remember this rule is important. The rule for creating a geometric sequence is a sub n, so any term, equals a sub 1 times r to the power of n minus 1. And those are both little ones. So that's saying a term in a sequence equals the first term times the common ratio to the power of n minus 1. Remember, n is the position of the term. So if I was looking at the fifth term, n would equal 5. So let's move on and use this rule to actually create our own explicit rules for geometric sequences. I have a sequence. It's 2, -8, 32, -128. And I'm going to come up with a rule that represents this sequence. So the first thing I need to do is identify the common ratio. Let's take a look. We have our second term is -8, the first term is 2. So that simplifies to give me -4. I'm going to check the third term compared to the second term just to make sure this ratio is constant and that this really is a geometric sequence. So the first time I got a ratio of -4, second time I got a ratio of -4, I can go ahead and say that my common ratio is -4. Step 2 is for me to identify the first term. Well, the first term in this list was given to me, and it is the 2. So I'm going to say a sub 1 equals 2. The first term is 2. Now that I have the ratio and the first term, I can go ahead and substitute these values into the rule. Remember, the rule is a sub n equals a sub 1 times r to the power of n minus 1. So I'll do a sub n equals, I need to substitute a 2 in place of a sub 1. Then in place of r, I'm going to substitute -4, and then we have to the power of n minus 1. This can't be simplified any further because the 2 and -4 cannot be multiplied until we get rid of the exponent. So I just need to do my final step, which is to check the rule. In order to check the rule, Instead of writing a sub n, I'll write a sub 1 equals 2 times negative 4 to the power of 1 minus 1. So I'm looking to make sure the first term does actually equal 2. That means I have to replace every n in the rule with a 1. So that gives me 2 times negative 4 to the power of 0. And I know that anything to the power of 0 is just 1. So it's saying that the first term is 2. If you check up here, you see that the first term in the list is 2, so that's correct. When you're checking, it's wise to do more than just one term. So this time I will replace every n with a 2. The second term is 2 times negative 4 to the power of 2 minus 1. I simplify my exponents and get 2 times negative 4 to the power of 1. Negative 4 to the power of 1 is just negative 4. And 2 times negative 4 is negative 8. If you look up at the list, you'll see that the second term is negative 8. And you can go ahead and check the third and the fourth term as well to make sure that this sequence is represented by the rule a sub n equals 2 times negative 4 to the power of n minus 1. So let's just quickly jot down a little side note. When you are creating a rule for a geometric sequence, or really an arithmetic sequence, you need the first term and you also need the common ratio. Without those two, you cannot create a rule. If they are not given to you, then you will need to figure out what they are, just like we did in this example.